viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabhat College, University of Delhi. In our previous lecture we have seen the basics of file system interface, and in our current lecture we are going to further talk about the details of file system interface. So, in our previous lectures we have seen what are the commonly available file types, also what kind of operations are being performed on a particular file, and today we will start with the basic file system structure. So, when we talk about the structure of the basic file system, so basically this file system requires only issuing some generic commands for the appropriate device driver, mainly for reading and writing these physical blocks on the disk. Now, what kind of physical blocks we are considering here? These physical blocks can be recognized by its number, numeric disk address we can say. So, for example, drive 1, cylinder 62, track 2 and sector 14. So, this is actually a a numeric disk address, and with this numeric disk address a physical device can be recognized, and on this physical device logically related data which is we are recognizing or we are considering in the form of a file is being written. So, basically this file system requires issuing some commands for writing and reading these physical blocks on the disk. Now, in order to implement a file system, we can say there will be various configurations which are available on disk or which are available in memory, various configurations and structures which are used for implementing a file system, and these structures and configurations basically differs on the basis of operating system and also on the basis of file system which is to be implemented, but they all have some general principles. Now, which general principles I am talking about? Now, different file systems can be there like NTFS and so on and so forth, but all these file systems have some common principles. One which are there is a boot control block which usually contains the information required by the system for booting an operating system from that particular volume. So, for example, we have a disk and we need to boot that. So, in order to boot, whatever information is required is actually stored in the boot control block. When the disk do not contain any operating system, this block can be treated as empty. So, if there is any operating system, this block will be having an information for booting that operating system from that particular volume, and typically we can say this is actually the first chunk in the volume or in that drive volume we can say, and in NTFS it is the partition boot sector, or it can have various names under various file systems implementation. A volume control block holds the volume or the partition details, such as what kind of partition details, such as number of blocks in that particular partition, what is the size of block for that partition, or what is the size of the chunk, then free block count along with some free block pointers, whatever space or whatever block counts are available. In case of NTFS, it is stored in the master file table. A directory structure per file system is required for organizing the files. So, each and every file system is having a directory structure in order to keep the files organized or keep the file structured. In NTFS, it gets stored in the master file table. This file this directory structure is stored in the master file table, and it uses the form of relational database management structure. That means one row per file is being stored, and in this way this we can say directory structure per file system is being what we can say is stored. Now with this details of file system, that means there is a we can say a chunk or a particular space on which the operating system files which are required at the time of booting are being stored, and this is basically the first chunk we can say in the volume. Then how this file system is being stored in the form of a directory structure which which follows the structure of RD relational database management system. That means in the form of tables, which is the we can say intersection of which is formed using rows and columns and so on and so forth. Now with this some a pointer or a command for reading and writing is able to access a file. Now how this file can be accessed will be defined by the access method. Now there can be various types of access method, but there are two access methods which are very important. One is the sequential access. This is one of the simplest methods in which the information in the file is accessed or processed in the order, that is one record after the another. So for sequential access we generally place a particular or we generally give example of the cassette player which was used in the earlier systems for sounds. So in order to hear the song number 2, you need to at least hear the song number 1, or at least kind of we can say fast forward it. That means 2 can be accessed only after accessing 1. So that's what the simplest method, which is sequential method, is. And this mode of access is by far the most common. But typically editors and compilers usually access files in this fashion, because for editors and compilers it is actually beneficial to use this sequential access method because of their application demands. So here in this on the screen, if you can see, there is the file on the there is the current pointer, and we have beginning of the file, then we have end of the file. Now from current position, if we want to go forward, we can simply go by either reading or writing. We can simply move our file pointer, but if we actually want to go to the beginning, we need to rewind the whole thing, and this is what your we can say sequential access type is. Typically we can say that. Apart from this sequential access, we have another method which is direct access. Now direct access is also known as relative access. A file here is basically made up of some fixed length records which are logically related to each other, and the programs or the system calls are allowed to read and write these records rapidly in no particular order. So for example, we can say as we were discussing the sequential access, we have taken the example of our cassette player, and as far as example of direct access is concerned, we have a CD drive, or the access onto the CD is actually a type of direct access, in which in order to reach on the second recorded, or in order to listen to the second song, it is not necessary to listen or to fast forward the first one, because this direct access method is actually based on the disk model of a file, since the disk allows the random access within the file to any block. And for the direct access, the file is actually we can say considered in the form of a numbered sequence of blocks or records. So presently, let us say the pointer is at block number 14, reading block number 14, and we want to let us say read block number 73. It can be directly done, and if we want to further write, let us say block number 17, that can also be done. What I am trying to say here is, the bottom line is, there are no restrictions on the order of reading or writing for a direct access file as it was in the sequential access. These direct access files nowadays are of great use for immediate access to the large amount of information, and our typical databases uses this direct access direct access method, because when a query concerning a particular entity arrives, we just see that which block is containing the answer or which block is containing the information related to that particular entity, and the pointer directly goes to that particular block and provide the desired information immediately. For example, let us say we have an airline reservation system in which information related to a particular file, for example, is stored in the block identified by that file number. So, for example, the flight number is 713. So, the block is also 713, which is containing the information about that particular file, and the number of available seat for that particular file, and other information is stored into that particular record itself. So, we can directly go to that particular block number in order to access the flight information. So, to store the information about a larger set, let us say people, or maybe these flights or something, we can also devise a strategy of computing a hash function on the people's name, or search a small in-memory index to determine a block to read and search. So, for example, if we having some numeric information, for as we have seen in the example of flight reservation system, that can directly we can say serve the purpose of the block number. But if there are the informations, for example, such as let us say some people, then we may need to compute a hash function on the people name, or maybe or any of the primary key, in order to determine the address or the index of a particular block. Also, when we talk about the direct access method, the file operations must be modified to include the block number as a parameter, because block number is very important. Then only a direct access method will be able to reach to that particular block. So, for example, when we say that in the sequential access, a normal system call or normal command can be read next, while in our direct access, instead of read next, it should be read n. So, n here is the block number, and then directly that n can be accessed. Then instead of, or rather than write next as in the sequential access, it should be write n. That means directly go to that particular n and then start writing. So, we can say that an alternative approach is to retain the read next and write next as with the sequential access, and also to add an operation position file n, where n is the block number. So, we can have this read n and write n. Instead, we can also have file n, which is for the positioning, and then we can say read next or write next. That can also be we can say that can also be done. Also, the block number provided by the user to the operating system is normally a relative block number, which this relative block number is an index relative to the beginning of the file. So, for example, the first relative block number of the file is 0, the next is 1, and then so on and so forth, even though the absolute disk address may be 14703 for the first block and 3192 for the second. So, absolute block addresses will we can say vary, because the block numbers are generally given in the relative format. Also, the use of relative block numbers allows the operating system to decide whether this file system should be whether the file where this file should be placed, and this allocation problem can be tackled very efficiently, we can say, with the help of relative block numbering. With this access methods of files, which are sequential access and direct access, let us come to the topic of directory and disk structure. This is actually very relevant in accessing the file, or in the storage of the file. So, in order to understand the whole system or whole file system interface, it is important to consider the directory and disk structure. Now, when we talk about directory, this directory can be viewed as a symbol table that translates the file names into the directory entries. So, here are some file names and corresponding directory entries, that means in which particular directory it is being stored. So, this there is a symbol table which is going to translate file name into a directory entry. But this directory itself can be organized in many ways, and this organization must allow to insert entries, to delete entries, to search for a named entry, and all these entries corresponding to various files and subdirectories also, and to list all the entries in the directory. So, with this background, that these all operations can be or these permissions this organization must allow, we need to see what all operations can be performed on a directory. So, in order to perform various what are the various operations which can be performed on directory are, one is to search for a file, another one to create a file within that directory system, then we have deletion of a file, then listing a directory, renaming a file, and traversing the whole file system. These are the common operations which are required to be performed on a directory, and this with all these operations, we have also seen some of these operations in our previous file system interfaces lecture. Now, how are these files are actually logical entries, or we can say these files are actually stored inside the directory. Now, how these directories are arranged, we have some common schemes for defining the logical structure of a directory. So, the first logical structure of the directory says the directory is in the form of a single level directory, or the structure is in the form of a single level directory. The simplest, it is one of the simplest directory structures in which all the files are contained in the same directory. There are no subdirectories, there is just one directory, and all the files, whether it is relevant to one particular subject or relevant to another subject, all these are contained in the same directory. Although it is easy to support and understand, but this kind of arrangement or this kind of a structure is having its own we can say significant limitations, because all the files are being stored only in one directory. All the files must have unique names. So, for example, if 10 users are using that particular directory, it is very important for all the users to ensure that the files which or the names of the files which they are keeping must be unique, because all are going to be stored inside the single directory. So, the single directory structure is something which is similar to the figure shown on the screen. As you can see, there is a directory and all the files are stored in that particular directory. So, all the records, the hex, the cont, mail, data, test, everything is stored inside the single directory. Now, as the data or as the number of files become huge, this single level directory become kind of we can say unmanageable, because each and everything messed up inside a single directory won't go along too long. In the next scheme of this organization of directories, we have a two level directory. So, two level directory is having, in which each user is having its own UFD as in user file directory. So, each user has his own user file directory, and all the user file directories have the similar structures, but each of them lists only the files of a single user. So, in order to see the a two level directory, let us see this on the screen. we have a master file directory which is having user 1, user 2, user 3, user 4 all combined in one in a master file directory, and then we have corresponding to user 1 we have different directories, corresponding to user 2 we have different directories, corresponding to similarly to corresponding to user 3 and user 4, and within those directories users are supposed to store their files. So, for example, user 1 is storing their file in its UFD1, user 2 is storing its file in UFD2, and user 3 is storing its file in UFD3, and so on and so forth. And this UFD1, UFD2, UFD3 all are stored in a master file directory. Now, how this is actually implemented is, each user gets their own directory space, and file names will only need it to be unique within a given user's directory, because now directory of one user is not interfering with the directory of the another user. And then there is a master file directory which is used to keep the track of each user's directory, and this master file directory must be maintained when users are added or removed from the system. So, when a user is added, this master file directory is to be updated, and when the user is deleted or removed from the system, again that master file directory has to be updated. And also a separate directory is needed for all the system or all the executable files, we can say. Now, system in this two level directory structure may or may not allow the user to access other directories besides their own. Then if there is an access to if there is a provision to access other directories, then it must be specified to the directory being accessed. That means specific provisions should be made if we want one user to access the other user's directory. If an access is denied, then a special consideration must be made for the users to run the programs located in the system directory. And also here comes the concept of the search path, which is the list of directories in which to search for the executable programs, and can be set uniquely for each user. So, search path in which the user wants to search the executable files for its own use can be set uniquely for each and every user. Apart from this, this we have seen single level directory, then we have two level directory. We have another logical organization of directory, which is a tree structured directory. This tree structured directory is one of the most commonly used as we use it nowadays. So, here you can see it on the screen. We have a root directory, and within that root directory we have various subdirectories. Within those subdirectories we can have files and other subdirectories as well, and the height of this tree can be we can say it is arbitrary. So, we can extend the directory structure to a tree of the arbitrary height, unlike the previous versions in which only either one level is there or at max two levels were there. This generalization allows the user to create their own subdirectories and to organize their files according to their own convenience. And a tree is the most common directory structure, as I have told you. It has a root directory, and every file in the system is having a unique path name, and it is, we can say, it is an obvious extension to the two-tiered directory structure, and this is the most familiar, most prominently or most commonly used nowadays. Each user or each process has the concept of a current directory from which all the searches takes place, and this concept of current directory is actually relative. Then files may be accessed using either the absolute path names, that means the complete path names, or the relative path names, which comes as in relative to the current directory, or if I am talking about the absolute path names, that means absolute path names, a complete path name starting from the root of the tree. So, for example, if you can see on the screen, and we can see that last level on the left side we have this file first. So, in order to search the file here in the first, we can specify the path that in the root, then we have spell, then we have mail, and within the mail we have PRT, and then within the PRT we have the first. So, this is actually a complete path, we can say, or absolute path for a particular file. Then directories are stored the same as any other file in the system, except there is a bit that is going to identify that whether this is a directory or it is a file, and this bit is actually, we can say, understood by the operating system. Also, one question which is under consideration is whether it is allowed to have the removal of the directories that are not empty. Windows here requires the directories to be emptied first and then removed, while the Unix provides an option for deleting the entire subtree. That means even if the directories are not empty, they can be deleted. So, this was the provision with the earlier Windows and the Unix operating system. So, here in this lecture we have studied many concepts related to the basics of file system interface, and also we have seen the directory level or disk structures, how these are arranged in the form of a single level directory or a two level directory or a tree level directory. We have seen these three. Also, we have seen access method, sequential access, and direct access. Here is a list of references which is being used for the preparation. Hope you have enjoyed the lecture. I will see you in the next one. Thank you.